Hello. So today, the topic is on classical statistics. Mostly, we'll discuss the concept of macrostate and microstate, and then we'll go the elementary concept of ensemble. Now, thing is that what exactly the microstate? A microstate is defining the state of the system, say a system of particles with the physical quantities of the constituent particle. For a single particle, in that case, we cannot speak of pressure P, volume V, and temperature T to identify or specify that single particle. Then what to do in that case? For example, say we are considering a number of particles. Here you can see the number of particles here. And so for example here, these are the number of particles. So how to just address individual particles? In that case, it is better if we can address the position and momentum at a moment. So in that case, two parameters, the position R in that case, the position R and momentum P. Consider this one particle with position say R1 and its momentum is given by P1, and another particle, say particle number 2, its position is given by R2 and momentum by P2. Obviously, the position vector are three component XYZ position, and the three components of momentum Px, Py, Pz. So these two parameters, there is a position and momentum at a particular time, can be used to address the single particle. If it is so, then for n particles in a box, n particle, microstate is specified by a set of their positions and momentum, right? So in that case, there will be total number of 6 n parameters. Say for example, for particle number 1, R1, particle number R2, then Rn. Similarly, the momentum P1, P2, Pn. So if it is so, each of these vectors has three components. The whole lot represents 6n dimension space known as the phase space of n particle system, right? Means for particle number 1, R1, P1, for particle number 2, R2, P2, for particle number 3, R3, P3. Similarly, for nth particle, the position Rn and momentum Pn. So altogether, if you consider all these positions and momenta, then there are 6n parameters which can represent 6n dimensional space and that space is represented as phase space for n particle system, right? Now, we'll give one very small example for the microstate. So here, if we talk about a point in this 6n dimension space, that point will represent one microstate. Understand? Say, in this 6n dimension, for a particular particle, there are, say, R and P. So there are the parameter for position R and momentum P. So at a moment, say at a glance, I've taken total scenario of the system. So particle number one value, that's one pair of values. Particle number 2, another pair of value. So in this way, we see that as a whole for the system, 6n number parameters are there. So in 6n dimension, if we put one point, that point represents the one state or microstate. Now give one example, one small example. Say we are considering 6 into 6 checkboard. You can see here 6 into 6 checkboard. So now, for example, if we take this example, see this is one checkboard here, one checkboard is here. So it has total 36 cell, 6 into 6 checkboard. And we put here the particle which having spin up, that is represented by, say, X. And if we put one particle with spin down, then that spin is represented by cross. So if the spin up, that marked by X, if spin down, marked by 0. So altogether 36 particle is placed in this checkboard in 2 dimensions. Now see how many ways we can place the particle here. For example, we are talking about here. So for example, say spin up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 spin up and 21 spin down. So this is one, say, one configuration. Now, if we take the total configuration of this 36 particle, then we have one thing, that some particles spin up, some particles spin down. So this is one configuration. So for example, I change this arrangement here. See, in this cell, the particle spin down, and here the cell particle spin up. So this is another configuration, taking 36 particles in different spin alignment into another configuration. Now question comes, how many ways we can arrange this checkboard, so which contains the 36 number of cells? How many ways? I mean, somewhere we put spin up, somewhere we put spin down. How many ways we can draw this checkboard? The answer is, since only there are two possible configuration, either spin up or spin down, and since there are 36 cells, so we can find a way of configuration 2 to the power 36. That is approximately 6 into 9 into 10 to the power 10. So in these ways, that means almost 700 crores ways are there. We can put the particles, or we can draw this much number of checkboard, right? So this is each and every arrangement or checkboard is known as one microstate. Understand? Now, if we talk about equal priority, means in any of this configuration, all these particles may exist. Then each one arrangement having same probability. So the probability of each particle will be 1 upon omega. So this is the probability of each configuration, right? Next comes, so we take, so for example, now we talk about the specific number of microstate we want to know, where, say one query, so where all 36 particles are spin up. How many combinations possible? Let's understand. Say for example, we have 36, all particles will be up. How many ways we can figure this? Simply this is, you can see here, all particles spin up. So only one way you can put this. So out of these 36 cells in this checkbox, if I want to put each and every particle which spin up, only one way of configuration is possible. That is only one, right? Say for example now, so this way of configuration of microstates is known as macrostate. So macrostate means that the combination of all microstate which maintain a particular combination. Here the particular combination means that all spins will be up direction. So this is particular configuration. So out of this 6.9 into 10 to the power 10 microstates, only one number of microstates possible to have all spins up direction. So this combination of such kind of microstate is known as macrostate. Then what is macrostate? Macrostate means the combination of all microstates subject to maintaining some special condition. When clubbed together, they make one macrostate. Next example, say we want to know only one spin will be up direction. Means that out of these 36 cells, only one will be arranged with spin up direction. How many ways we can just arrange this? You can see here that this is one left top cell. Here you can see left top scale here. Left top scale here you can see. This is the one spin which can be put with spin up direction. So this is one arrangement, means that only top left corner cell with spin up direction. others are all spin down. Because question is here, you find the microstates with one only spin up. So this is one combination with all this 36 cell. Next combination you can see. Next combination you can see how. So these are one. That means here you can see the second one. Similarly, the second one you can see the second one here with this combination, right? So this is another combination. This is another combination. Next, another one. Here you can see. Here, just I put another combination here. You can see that this is one with one spin. So this is one. This is one. You can see. This is one. This is two. This is three. So in this way, if we proceed, you can see that altogether we can arrange 36 ways. So what we see here, that if we take only one cell will contain spin up, then in a 36 ways we can arrange. Each and every cell will be one spin up. So out of this 30 cell, you can arrange 36 ways. So we see that out of 6.9 into 10 to the 10 microstates, 36 microstates are such type which contains only one spin up. Then we will say that this number of 36 microstates form a macrostate. So previous one, you see here, the previous one, sorry, the previous one here, this is one. That means the number of macrostates which contain all spin up, all microstate spin up, only we get one number macrostate. Now only one will be spin up. We get 36 number of such kind of microstates which form another macrostate. So the combination of microstates subject to fulfilling some conditions, a common nature, forms the macrostate. So this is the another macrostate which is defined by only one spin up combination, right? Next go. Next go, let's see that, say, how many microstates with 13 spin-up combinations we can get. Let's see. So, till now, we have discussed how many microstates having all spin up, how many microstates? Only one. Next, we given the example, how many microstates where out of 36, only one will be spin up. There are 36 microstates. Now, similarly, we are thinking another example. How many microstates are there where 13 spin will be up? Let's see. It means that now we are going to another macro state which will contain 36 spin up direction. How many such microstates can be taken? Let's see. So this is one example you can see. The first one that you see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these 13 cells having spin up. So this is one microstate. Here you can see 13, but different configuration. This is another microstate. Here you see 13 spin up, but different combination or arrangement. So this is another microstate. So how many such way we can prepare number of microstates? So how many possible such microstates are there? In that case, we have to go the combinatorial concept or combination. That means basically you are splitting n identical objects into two smaller groups, one having spin up n up arrow and remaining the n minus n number particle with spin down, right? So then how many ways we can arrange this? This is simple mathematics, the combination. It means that out of total number of cell n, total number of n microstates, we are considering small n up arrow number of microstates where 13 spin up. Say for example. So how many ways we can just arrange them? Simple NCR, that how many we are taking here. So capital N for our example is 36 and small n is 13. So you put the value here. That means out of 36 cell, how many ways we can put 13 cell with spin up? How many ways we can arrange this? This is simply NC, N up arrow, and then combination formula, NCR. Then we put capital N as 36 and small n up as 13. Then you calculate this, then it will come as 2.31 into 10 to the power 9. It means that out of 6.9 into 10 to the power 10 number of total microstates, 2.31 into 10 to the power 9 microstates are there, which contains 13 number of spin arms. So this is one macrostate. This macrostate is defined by NCN small n up. Means that microstate I need where out of all 36 microstates, 13 will have spin up. So this is one category and one macrostate, right? Next we'll go the number of way to create macrostate. Then this formula just now I mentioned. Now question is that then how many total macrostate will be available? It depends on the value of small n in arrow, up arrow. So n can take value from 0 to 36. So altogether, 36 number of macrostate is possible to get. So finally, we come here that out of this 36 cell of this checkbox, there are 6.9 into 10 to the power 10 number of microstates and only 36 number of macrostates. And each and every macrostate, how defined? Is defined as the macrostate contains the number of microstates which contain the similar number of upspin. So this is the macrostate. Next comes, then what do you mean by multiplicity of two-state system of this macrostate? Multiplicity means that how many number of microstate exist in a macrostate. So multiplicity of a macrostate is defined as the number of microstate exist in that particular macrostate. So this is here, omega n0 means that total number of microstate is capital N, and out of this, no number of spin up, that is 0 number. How many microstates available? 1. So for this macrostate omega, for this macrostate omega macrostate, the multiplicity is 1, right? Similarly, say for example, N1 macrostate. For N1 macrostate, how many number microstate is there? It means that only one spin will be up. How many? Total number of N, the total number of microstate. This number of microstates will be there. So for this macrostate N1, the multiplicity is N. Similarly, N2, this macrostate, simply NCR, you put NCR, N into N minus 1 by 2. So this number of microstate will exist into this macrostate. So multiplicity of omega N2 is N into N minus 1 by 2. Then N3 similarly like this, N3 similarly like this, and then the general formula, what is the total multiplicity or number of microstate in a macrostate which is defined by capital N small n, NCR. The formula is n factorial divided by small n factorial, n minus n factorial, means the multiplicity of the macrostate of a two-state spin with n up is right. So now comes the probability of macrostate. Probability means the occurrence of that microstate. So the probability means the total number of all microstates. Out of this, the number of microstates corresponding to this n up number of spin. So this is simple ratio. Then total number of all microstates is 2 to the power n. The probability of this macrostate of a two-state spin system is omega by 2 to the power n. Now, what is the value of omega? It is simply NCR. So n cap, n factorial, n up factorial, n minus n up factorial divided by 2 to the power n. And if we go for approximation, then if the system is very large, then we get this formula. Okay. So now we go, set capital N equal to 1, put here. So we see that the probability of this macrostate is 0.5, which exactly here you can see here. Similarly, if we take the probability of different n cap value, so we see that here is the variation is here. So if the system becomes very large, then this graph becomes more and more sharp. And if it is very sharp, then we see that the maximum probable macrostate having the probability is here. That is just middle of here, which is nothing but talking about the random orientation of spin, or which is a consequence of second law of thermodynamics. So this is about the concept of microstate and macrostate. So basically what we learn, if we summarize this, microstate is the total number of ways a system of particle can exist. That is the microstate. And macrostate is subject to a particular fulfilling condition, fulfilling that some microstate can exist in that mode. The combination of all these microstate give the macrostate. And macrostate is defined by omega n comma small n. Means that out of total number of capital N number of microstates, how many microstate of small n number maintains some special condition? If so, that combination or that group is known as one macrostate. So microstates, the individual level or the individual particle property, and macrostate is giving the idea regarding the overall use of the system of particles. That is macrostate. Or you can correlate the macrostate with some experimental value or average value of the system. So this is the concept regarding microstate and macrostate. Okay, thank you very much.